Next, we're going to be dividing complex numbers. The following division problems are not considered totally simplified because there is an I in the denominator. And therefore the expression can't be written in a plus bi form. So on the first problem, we have an I in the denominator, and therefore we have a plus bi form in the top, but divided by imaginary, well, that's not in a plus bi form. On our next problem, we have 2i divided by a complex number, 3 minus 5i. Okay, there's an I in the bottom, and I can't write that in a plus bi form if there's an I in the bottom. So the process that we're going to do to divide complex numbers is actually very similar to rationalizing denominators when we have radicals in the denominator. So we're going to be comparing each of these processes to radicals over the next couple division problems. First, we will divide complex numbers with monomial imaginary denominators only. Okay. So before I actually show you how to do the monomial denominators, okay, this is a mono because there's no adding or subtracting. So before I do that with imaginaries, I am going to remind you how to do it with radicals. Okay, so on this problem, we were going to multiply by some radical in the numerator and some radical in the denominator so that we would get something that we want. Now the 5 was already outside, we don't have to worry about that one. But underneath the radical I have a 2. And in order for that 2 to come out, I need 2 copies of 2. So how many more copies do I need? 1 more copy. Whatever you do to the denominator, you're going to also have to do to the numerator. So looking at this green denominator here, I have a 5 on the outside. This group of 2 also comes outside, which gets me the square root of 10. In the numerator, that gets me 3 times the square root of 2. So my final answer is 3 square roots of 2 divided by 10. Now when we're dividing complex numbers with monomial denominators only, monomials, just like we did over here with monomial radical, we are going to follow the following steps. Multiply the numerator and denominator by I to get the imaginary number out of the denominator. So just like before, we had to multiply it by something that was convenient, so we got 2 copies of it. In this case, I'm going to be multiplying by I to get the imaginary number out of the denominator. Next, we're going to simplify and rewrite in a plus bi form. Again, this only works if there's a monomial in the denominator. So I am going to multiply by I over I. Whatever you do to the denominator, you must also do to the numerator. This gets me in the denominator 2i squared. And I needed 2 copies of I so that I could change that denominator to be 2 times negative 1, which is just negative 2. So I have successfully got the denominator to not have any i's in it. Now I'm going to go back and apply the numerator. So that gets me 3i minus 5i squared. I squared in the numerator, that can be changed to a negative 1. Negative 5 times negative 1 is positive 5. Now, please remember that it has to be rewritten in a plus bi form. So the 5, which is a real number, should go first, and the plus 3i, which is an imaginary number, should go second. Now, this is still not quite in a plus bi form. This is an a plus bi divided by a real number form. So to make it all the way in a plus bi form, we're going to take the 5 over the negative 2, and then we're going to take the 3 over negative 2. 3 divided by negative 2 is negative 3 halves I. So that negative in front of in the denominator could possibly go out in front to make it a little bit neater. And that is my final answer. Let's practice this some more. On the next problem, we have 4 plus I over 3i. Again, in the denominator, I have a monomial with an imaginary number. To get that imaginary number to not be there in the denominator, I am going to multiply by I. Then in the denominator, I get 3i times I, which is 3i squared. And I squared is a negative 1. I needed 2 copies of I so that the I squared could become a real number, which reduces to -3. Okay, so I've successfully got the I out of the denominator. So now I have to be fair. Whatever I do to the denominator, I also have to do to the numerator, which gives me 4I plus I squared. Now we know that I squared can be rewritten as -1. Step 2 says to make sure you simplify and rewrite in a plus bi form. So the -1, which is real, needs to go in the front. The 4I, which is imaginary, needs to go in the back. And the last step is to write in a plus bi form, because this is really a plus bi form divided by a real number. So that's not really a plus bi form. So I'm just going to take -1 divided by -3, and that gets me 1/3. And then I have 4 divided by -3, which gets me -4/3 I. And that's my answer. On our next problem, we have 6i in the denominator. Again, it's a monomial. No pluses and no minuses. We will deal with when there's a plus or minus there, but we're going to use a different method. So if there's a monomial in the denominator, I'm just going to multiply by I. And the reason I'm going to multiply by I is because I need 2 copies of I in the denominator, so that becomes a real number, because I squared is a real number, -1. So I've successfully got the denominator to be a real number, -6. Now I have to go back and be fair and do everything, whatever I do to the numerator, I have to do to the denominator, which gets me 2i plus 3i squared. We know that any I squared is -1. 3 times -1 is -3. I'm going to put that one in the front. The reason I want to put it in the front is because that's a real number, whereas 2i is an imaginary number. Now this is not quite an a plus bi form. I need to write it, split it up, so that gets me -3 over -6. I'll reduce that in a minute. Plus 2 over -6i. Now this truly is a real part plus or minus the imaginary part. Okay? So the real part reduces to a half. Positive 2 divided by -6, that's -1/3 I. And that is my answer in a plus bi form.